Here is an explanation for the answer to final exam question number 65, found on page 380 of Trigonometry Demystified, 2nd edition. Although the drawing does not specifically apply to this problem, that is figure exam-7 at the bottom of the page, it can serve as a good illustration to answer this question. If we want to measure the distance to an object based on parallax, which is what we do when we measure the distance to a nearby, in relative terms, star from our solar system, when we want to do that, we must always make certain that one of the following things holds true. Well, we need to make certain that this line or this line, one of the observation lines between us and the distant object, is precisely perpendicular to the baseline of our observation. That is to say, the baseline runs perpendicular to a line connecting one observation point to the distant object. That is choice B. Now you look at the other choices. The baseline is as short as possible. This line? Absolutely not. Choice A is definitely wrong. We want this line to be as long as possible, because when it's short, this angle here becomes extremely small and therefore extremely difficult to measure in the real world. Mathematically, the process may still work perfectly, but in the universe, our measuring instruments are anything but perfect. So these tiny angles, a very, very tiny error in the angle measurement, when the angle is really small like that, will result in a tremendous error in the measured distance. The baseline runs parallel to a line connecting one observation point with the object. That would be choice C. Well, absolutely not. If the baseline were parallel to either of these, we would have a meaningless state of affairs. We wouldn't even have a triangle. Choice D, the reference objects that we use to determine the parallax are closer to us than the object whose distance we want to measure? Absolutely not. The objects that we use to measure in a case like this, a classical case of parallax measurement, the background of distant stars needs to be many, many times farther away than the nearby star. In fact, so far away that parallax essentially doesn't occur at all for them. And that's not hard to do in a galaxy as big as ours. Only the very nearby stars, in relative terms, can be measured this way. E, the observed parallax, is as small as possible. Well, this is the parallax angle right here. The smaller that gets, the tougher it is to get an accurate measurement of the distance, because, again, the error in our measuring apparatus is going to be an absolute error, which will become a larger and larger fraction of this angle as this angle gets tiny. In fact, if it gets too tiny, we won't even be able to measure it within the range of 0 either way. So we'll get an inability to measure the angle if it's too small. No, E is definitely wrong. Once again, choice B is correct. We want this baseline to be perpendicular to one of the observation lines. In this drawing here, it's this one. It's the one where the Earth lies directly between the sun and the star. Again, choice B.